1 is 0 and negative exponents. I want you to copy down this chart. It is in your textbook. And we're going to come up with some kind of rule, a conjecture. We're going to come up with some kind of rule for negative exponents. So when we have a number raised to an exponent, you guys know how to do that, right? When we have, for example, 2 to the 4th, 10 to the 4th. You know that 2 to the 4th is 2 times 2 times 2 times 2, right? So that would be 16, right? So we've got 16. And then on the other side, we have 10 times 10 times 10 times 10, right? That's 10 with 10 times 10. That's 10 with 4 zeros. That's 10,000, right? 10,000. Okay. 2 to the 3rd is 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 8. And then over here, this is 1,000, right? Then 2 to the 4th, 100, right? This is 2, 10. Huh. So if we look at this pattern, you see it's divided by 2 each time, right? So here, this is going to be 1, right? And then over here, let's see, every time we come down, we're taking a 0 off, right? So here, if I take a 0 off here, this is going to be 1. Now, if you notice here, 2 to the 0, 10 to the 0. We've already talked about that before, right? Anything raised to the 0 is going to be 1, okay? So we already knew that. Again, dividing by 2 each time, right? Dividing by 2 each time. So, what would this be?
You flip it into a fraction, and then you still have
Still dividing by 2, right? So here, so if you look at that, just like you said, if we put this over 1, we flip it, and then the exponent becomes positive. You see? So on this side, what would this be? 1 over 10. You got it? Then over here, for this 2 to the negative, again, we're going to flip the fraction, right? We're going to flip the fraction, so it's going to be 1 over 2, and when you flip it, the exponent becomes positive, right? The exponent becomes positive, right? So that's going to be 1/4. Okay? But the rule that you need to remember is that when you flip the negative exponent becomes positive. So then on this side, when we flip it, it's going to be 1 over 10 to the second. 10 to the second. So that's going to be 1 over 100. Is everybody clear? So the rule that we can figure out, that we can see when we come down to the negatives, when we come down to a negative exponent, the rule is that you're going to put it over 1, flip it, and then the exponent becomes positive. You got that? So we already talked about 0 as an exponent. For every non-zero number, a to the 0 power is equal to 1. Anything raised to the 0 power is 1. So 4 to the 0, 1. Negative 3 to the 0, 1. 5.14 to the 0, 1. Right? If you have a negative exponent, here is the rule. You flip it. Okay? The 1 in the denominator goes to the numerator. the negative exponent and the base go down to the denominator, and the negative exponent becomes positive. So over here, for these examples, 7 to the negative 3, if we put this over 1, you can see that when you flip it, the 1 goes to the numerator. The 7 and the negative 7 to the negative third comes down to the denominator, and when that whole thing comes down to the denominator, the exponent becomes positive. You see? Over here, remember when you have a parentheses, it's everything in the parentheses. Okay? So when you put this over 1, the 1 goes to the numerator. The negative 5 to the negative 2 comes down to the denominator. Now look, be sure that you pay attention to this. What becomes positive? Only the exponent. Does everybody see that? The base stays the same. Okay? Only the exponents become the opposite. Problem 1. What is the simplified form of each expression? Okay? And again, all you're going to do is you're going to put it over 1, flip it, then the exponent becomes positive. Okay? So, we're going to put this over 1. We're going to flip it. And then we end up with 1 over 4 to the third. Okay? Now, if they say, what is a simplified form? Is this simplified? No, this is not simplified. You have to multiply that out, right? So, you go to your calculator and you write, you have the y to the x. 4 raised to the third power is equal to 64. So this is going to be equal to 1 over 64. For letter B, do I have to show any work on that one? No, because anything raised to the 0 power is equal to 1. No work necessary. For letter C, again, we're going to put that over 1. We're going to flip it. We end up with 1 over 3 to the second power, which simplifies to
1 to 9.
Not 1
1
2
9.
1 9. Very good. 1 9. Good. Here, same thing. We're going to put it over 1 and flip it. When we do that, we end up with 1 over 6 to the positive 1, 6 to the first, which when you simplify 6 to the first, that's just equal to 6. So that's 1 6, right? One 6. Okay. How about letter E? What's that going to be?
1 over 4 to 6 equals.
Does everyone agree?
Yeah.
What's wrong?
You have to keep the negative.
You have to keep the base the same, right? So this is going to be a negative 4, and we want to make sure we put that in parentheses, right? The base stays the same. So that's going to be a negative 4 to the positive 2. Only the exponent becomes positive, okay? And now we have 1 over negative 4 to the second power. What's that going to be? 1 over 16. Very good. What if I had this negative on the outside?
It would be negative.
It would be negative 1/16, right? Because the negative would have gotten applied later, right? So those parentheses are very important. So make sure you put those in. All right, an algebraic expression in simplest form when powers with a variable base are written with only positive exponents. Okay? So it's in simplified form when your exponents are all positive. Okay? So here, simplifying exponential expressions, we want to know what is the simplified form of the expression. Now, we already figured out for problem A, all we have to do is flip it, right? So when we flip this, we're going to get 1 over x to the 9. Very good. Now, for problem B, what happens when the exponent is already in the denominator?
You flip it.
You flip it again. You just go ahead and flip this. So now the negative exponent is going to go to the numerator. The 1 is going to go to the denominator. You see that? You're just going to flip this too. And we're going to get n to the positive 3 now over 1, which of course is just n to the third. And there's your simplified form. Got it? Ooh, look at this one. Letter C. 4c to the negative third times b. What am I going to flip there?
I know. You flip everything.
Do I?
No, you flip the thingy with the c as the third power.
The exponent is only connected to the what?
The base.
And the base is what?
The c.
The c. Don't get fooled by that 4, right?
Yeah.
That 4 is not part of the base. Just the c is. Let me highlight it. Yeah. Let me highlight that. Okay? So that is the only thing that's going to get flipped, right? So what I'm going to do is I'm going to put that over 1. Okay? So when I flip it, all I'm doing is just bringing it down to the denominator, right? And then the 1 goes up to the numerator. Ever see that?
Mm-hmm.
So when we simplify this, we're going to get 4 times 1 times b over c to the third. Does everybody see that? What's 4 times 1 times b?
4b.
4b.
It's a 42.
4b. And then in the denominator we have c to the third. Now, does anybody see, did I have to do all of this work? Putting the 1 under and all this? Can you see that all you're doing is taking this c to the negative 3 and bringing it down to the denominator? You see that?
Mm-hmm.
So for letter D, couldn't I just bring that up to the numerator?
Mm-hmm.
Very good. You see this? We can just take this and bring it up to the numerator. You got it? So this will now be 2 times what? A to the positive third, right? A to the positive third. See how simple that is? Uh-oh, how about this one?
Oh no. Yeah, flip it.
This one you gotta flip, right? Am I gonna flip the whole thing? No, only the part that has negative, right? What's gonna go into the denominator, what's gonna go into the numerator when I flip this negative down to the denominator? 1.
Because I write
1. The reason I'm not moving this m to the second is because, is that a negative exponent? No. So just like I did over here, right? I'm just going to put this over 1. You see that? I'm going to put that over 1. And that is the thing that I'm flipping. See? So when we flip it, the 1 goes to the numerator, right? And the n to the 5th comes to the denominator, and that m squared, that stays the same. So m squared n to the 5th. You got that? When you evaluate an exponential expression, you can simplify the expression before substituting values for the variables. Okay? You simplify before you substitute. Okay? So here we want to know what is the value of each expression in parts A through D for n is equal to -2 and w is equal to 5. So here, you guys, we want to simplify first and then substitute. Simplify first, then substitute. So, for letter A, we have n to the -4, w to the 0. What do you know off of that? Anything? Raised to the 0 is equal to 1. Very good. So this is going to be 1. And what am I going to do with this n to the -4? You're going to flip it, right? So that's going to come down to the denominator. Is it okay if I just do arrows like that? You okay with that? Okay. So, when we simplify, we end up with 1 over n to the 4th. So now, to evaluate, we substitute -2 in for 4. So we've got 1 over -2 to the 4th. So that's -2 times -2 times -2 times -2, which is going to be, there's 4 negatives up there. Remember, when you have 4 negatives, that's an even number. You're going to have a positive answer, right? So that's going to be positive 16. So 1/16 is your simplified form. Got it? All right. So for letter B, how am I going to do that? What should I do there? I am going to flip it, right? Well, once I flip it, though, what's going to go into the numerator? You got to have something in the numerator, right? Is the W going to move up? Right. If I put a times 1 down here, and you see that you're going to flip just that, right? When you flip that, then you're going to get 1 in the numerator, n to the first comes down here because now the -1 becomes a positive 1, right? And then the w squared stays there. Does everybody see how we got that? And of course, n to the first is just n, right? So now we can substitute, okay? So we're going to put a -2 in for n and a 5 in for w. So we have 1 over -2 times 5 squared. So when I simplify this, we get 1 over 5 squared is 25, and then 25 times -2 is -50. Good. All right, and then you're done. So letter C, I want to simplify, right? What do I know how to simplify right off the bat?
1
N to the 0 is equal to 1. Very good. N to the 0 is equal to 1. So that is 1. Do I need to flip anything?
No.
No. So now when I substitute, we have 1 over W. I'm just going to rewrite W equals 6. So when we substitute, we're going to have 1 over, what's W? 5 to the 6th power. And we want to simplify that. So that's going to be 5 raised to the 6th power, which is equal to? Very good. And there's your simplified form. Okay? Ooh, look at letter D. Ooh, D. What am I going to flip on that?
NW.
The NW?
No, it's a little.
Just the W, because the exponent is only connected to what it's right next to. If I had parentheses around the NW, then I would flip the whole thing, right? But since there's only there's no parentheses, the only thing that's connected to that negative exponent is the W. So let me highlight this. So the only thing that we are flipping is going to be, it's going to be this. You got that? Okay? So when we flip it, we're going to go ahead and flip that one. We're going to end up with W to now the negative 1 is going to become positive 1. And then the n down to the denominator stays down there. Of course, W to the first is just W. So now we substitute. So W is 5, and n is negative 2. So you have negative 5 halves. Okay? You might see in the textbook, when you check your answers, you might see decimals. So you can write negative 2.5. Problem 4 is using an exponential expression. You should write down the problem. A population of insects triples every week. The number of insects is modeled by the expression 5,400 times 3 to the W, where W is the number of weeks after the population was measured. Evaluate the expression for W is equal to negative 2, W is equal to 0, and W is equal to 1. Now, I want you to know that sometimes you will see it as W is equal to negative 2, 0, and 1 when they're telling you what to substitute, okay? So that just means that you're going to substitute negative 2, you're going to substitute 0, and you're going to substitute 1. Don't get confused by that. Is everybody clear? Okay. So we have 3 substitutions to do. And this means if W was negative 2, what does negative 2 mean? I know. What does it mean? What does it mean? Because it says here, W is the number of weeks after the population was measured. What? After. Very good. So that means that the population was measured 2 weeks before. Does that make sense? Okay? And W is equal to 0. When is that? Right. No, it's right when they start the experiment, right? They haven't done any measuring. That's when they start, right? And then, of course, W equals 1 means
1 week.
1 week
After.
after. Very good. All right. So when we evaluate, all we're going to do is we're going to substitute those values into our expression. So we have 5,400 times 3 to the negative 2. We have 5,400 times 3 to the 0. And we have 5,400 times 3 to the first. For the first one, what do I have to do with this? Negative exponent. You need to flip it. So we're going to go ahead and take this down to the denominator. So I'm going to go ahead and rewrite this. And we've got 5,400 over 3 squared. Right? So when we do that, 5,400 divided by 3 squared, of course, is what? What? 9. Oh, okay, sorry. Divided by 9. And so that gives us 600. And that's 600 insects. Right? For the next one, we have 5,400 times 3 to the 0. Of course, 3 to the 0 is 1. Very good. 3 to the 0 is 1. So 5,400 times 1 is, of course, what? Right. Okay, 5,400 insects. And of course, after 1 week, you can see, and it makes sense, that here, 600 insects, it would be less than when they started the experiment, right? Here's when they started the experiment, or the counting, and here is going to be after. So we expect this one to be bigger, right? More. So 5,400 times 3, 16,200. 16,200 insects.